So hey everyone, in the last video we had deployed our backend application to AWS, right? So we saw two approaches. One is deploying without Docker containers, and we already saw what is the actual problem, and then we actually deployed using Docker, right? So inside ECS we ran a task, okay, and then created a service to actually run the task, and we saw our application actually running. However, this is not the ideal approach, because I already told you a problem in the last video that this is completely cloud specific. Okay, so the basically AWS ECS is only limited to AWS and not any other cloud provider. Okay, so if I want to migrate from AWS to GCP, for example, so I will have to do all the steps manually. And another problem is when I deploy my Docker container on EC2, for example, so there suppose anytime the container shuts down for some reason, so I'll have to manually bring it up. So that is problem number one. So the another problem is, let's say I have a virtual machine which I have deployed on EC2, for example, okay, and I just pushed my container inside that. I ran Docker and I just executed the image by building a container and running my current application over there. So let's say for some reason this container fails due to some reason. So again, what I need to do, I need to SSH into the machine. I need to do a Docker run, and then I need to run it on the same port, that is 8080. So all of these steps I have to do it manually, right? So we just can't keep monitoring, right? So in case I have another EC2 machine which is running the same application, this also gets crashed, I need to run the same commands over here as well. So this is a lot of manual work, and this is the problem number two. And another problem is whenever I want to start a new image on the same container, so for some reason that image fails, okay, so it doesn't have any rollback options, right? So in case that container fails, even the previous container also will be failed, because I am actually replacing it, so there is no mechanism of rollback updates. Okay, so that is another problem that we are currently facing. All right, so all of these problems is addressed by one particular service which is used with Docker, that is Kubernetes. Okay, so we can also call this K8s because there are 8 letters between K and S, so that is Kubernetes. So basically a brief about this is like it's a container orchestration engine. Basically, you know what is an orchestra, right? So it keeps instructing the people by giving it instructions on how they need to perform. Same way it has to also give the containers instructions how it has to perform. Suppose if a container goes down and if you want to bring it back up, so we give it all the necessary specifications also, so like how many containers it has to run, and suppose if it also has features like rolling updates. So if any container fails, so if I want to bring up a new container and eliminate the previous ones, so it also does that. So in case if that fails, so the previous one will still be running. And also the main thing is that this is cloud agnostic. What do I mean by this? Basically, let's say in any cloud provider, every cloud provider will always have a Kubernetes engine which we can start clusters on that particular cloud provider service. So AWS has its own Kubernetes engine. So the same goes for GCP and Azure as well. So basically they have its own Kubernetes service. So I remember AWS has EKS, which stands for Elastic Kubernetes Service, and the same goes for GCP and Azure. So they have their own Kubernetes service. Basically what we actually need to do is spin up a cluster over there and then configure all of our application in there, which I will just come to that after this. So Kubernetes is not cloud specific, it's cloud agnostic, which means that in any cloud provider we'll have a Kubernetes engine, so there we can run our application and have the same benefits that it actually has. So basically the container orchestration. Okay, so previously if you remember the Docker approach which we did while deploying our application, so we used AWS ECS and ECR. So ECR, we stored our Docker image over here, and then we pulled it inside ECS and then ran a task. Okay, so the same thing will not be in GCP and Azure. Okay, so they have their own service. So this whole thing does the container orchestration itself. You see, if you remember from the last video, we had just specified the number of tasks, and if the CPU utilization goes above 50%, then increase the number of tasks. So in case if a container fails, so it has to bring back up. So we saw that states, right? So one is in pending state, and then if a container crashes, it will just make the rolling updates. So basically it will create a new container and then delete the previous container, right? So all of the orchestration does by this service which is actually only specific to AWS. So this is the very generic concept called Kubernetes, which works for any cloud provider. Let's say for example AWS increases the prices. Now I just want to move to another cloud provider. Again I need to explore all the features. I need to do the all manual stuff. So everything what I just need to do is write a config file. So basically we have a manifest file, so we just write all the instructions what exactly it has to do while running a particular container. So we call this as a manifest file. So it is similar to like the Docker Compose, which is actually written in YAML format. So I just need to tell Kubernetes engine to actually run this file. It will create all of my containers and then do everything that it needs to do. All right, so let us understand the concepts, what exactly we need to know inside Kubernetes. So just as I told, Kubernetes will consist of a cluster. Okay, so let me just consider this particular box to be your cluster. Okay, so in a Kubernetes cluster it contains multiple nodes. All right, so let me just consider 2 nodes for this example. So basically you can contain n number of nodes. All right, so whenever you are starting nodes, okay, so you need to start some nodes as worker and some as master nodes. Okay, so I'll just come to what are they actually. So let me consider this node to be a master node. Basically in a single Kubernetes cluster you will always have one master node and multiple worker nodes. Okay, so this is a worker. Basically these nodes are nothing but your EC2 machines or your virtual machines that is actually hosted on the cloud. Okay, not the master node but just the worker node, and one particular worker node will contain multiple pods. Okay, so basically a pod is the smallest deployable unit inside Kubernetes. Okay, so basically Kubernetes has a concept called deployment and it will deploy pods. Okay, and in turn pods will consist of containers. So if I just consider 2 pods over here, so this is pod 1 and this is pod 2. So these will contain multiple containers. Okay, so let me just name these. So this is a pod and these are containers, and this is the Kubernetes cluster. So Kubernetes will not manage your containers directly. Basically they manage pods. All right, so pod is the, as I told, it's a single smallest deployable unit, and pods actually run containers. All right, so this is basically the whole overview of a Kubernetes engine. So basically a Kubernetes engine will contain of a cluster, and then a cluster contains multiple nodes. One you need to start as a master node and multiple worker nodes, and each node will contain of multiple pods, and pods actually run containers. All right, so this is the entire concepts. Let us understand a little bit deep of how these particular containers are managed and what actually a pod is, and how exactly our pods are actually managed and containers are being orchestrated. So suppose for example a container goes down, and how does it bring back up? So let us learn about that. So basically this master node you see over here, you can also call this as a control plane. So basically this actually controls your whole Kubernetes cluster. All right, so you call this a control plane, and this contains multiple components. Okay, so basically there are 4 main components, so we can just draw them right here. So the first thing is the API server. Okay, so I can just say this as a API server. So basically we as a developer, we communicate directly to this inside this master node to this API server, and based on whatever we instruct to this particular server, it will go ahead and communicate further with our pods. All right, basically we have a command line interface called as kubectl. Okay, basically short for kube control. Whenever we start a Kubernetes cluster, we get access to our kubectl command line in order to communicate with our Kubernetes cluster. All right, so basically if you remember, we had created that I told you about that manifest file, right? So where we instruct how many containers or how many pods should actually run, and everything will be within that file. So we just need to pass in that particular file to our API server, and that will take care of itself. Okay, so how many pods should be deployed, and is the pod actually healthy, or how many containers running inside that, all of that manages by itself. But we as a developer, we just need to provide instructions from that manifest file, which basically we write it in YAML. All right, so this is the CLI. But all this information, how many pods are running, will not be stored within this API server. Basically it's stateless. Okay, it doesn't hold any information. There is another particular component called as etcd. Okay, this is basically holds the entire state of your Kubernetes cluster. Basically how many nodes are there, how many pods are running in each node, and how many containers are there inside that, so on and so forth. Okay, all your cluster information is stored in here. Based on this, it will take actions. And the third component is called as the kube control manager. Okay, sorry for my handwriting. Basically this continuously keeps checking whether our pods are actually healthy or not, and the number of pods that are actually running is equal to the desired number of pods that we actually specify within that manifest file. Currently we are having 2 pods. Okay, so within our file we have considered, let's say, 3 pods, so it will start another pod, and then I specify saying that I want only 2 pods to be running, so it will just scale down to just 2 pods and then check if all of the containers, or if the pod is actually healthy or not. Okay, so if it is not healthy, it will just keep running an infinite loop. So if it is not healthy, then it will bring back a new container up, okay, and delete the previous container. So that's the job of a kube control manager. Just as it says, it controls our pods. And the last component is called as a kube scheduler. So suppose we have multiple worker nodes. Okay, let's say I have this node somewhere right here. Basically it's inside this cluster itself. So if I have 2 nodes, and if I want to, like, let's say, start 3 pods, okay, so it will place where which pod actually needs to run in which node. Basically it will check which particular node's CPU usage is high or low. So based on that, it will place the pods over there. So basically if I have 3 pods, so 2 pods can run over here and another pod can run over here. Let's say I want to spin up another pod. So basically we have 2 nodes, so 2 can run here and 2 can run over here. Okay, so this is the job of the kube scheduler. So I hope you have understood the entire concepts of this master components. So basically we have a API server which we as developer communicate with it through this kubectl CLI, and then etcd is actually the brain of the entire Kubernetes cluster, which will store all the information, all the state of our cluster, and then kube control manager will actually continuously keep checking if the desired number of pods are actually running, and kube scheduler is actually the job where it checks where do I actually need to run a pod based on the CPU utilization and all that metrics. All right, so this is the actual functionality of this master node. So let us deeply understand how does a worker node, so what are the components are there inside that, and how does it communicate with the master node. So inside each worker node we have something called as a kubelet. Okay, so basically what this does is it communicates with the API server and it checks the pod definitions. Basically the actual containers that are described for a pod to run are actually running or not, and then it will check the health status and it will return back the information to the API server. So basically this actually is a term that manages pods. All right, and the next component we call this as a kube proxy. So basically this does all the networking stuff inside a particular node. So basically the network rules that we define, that it has to run on the specific pods, and whenever we create a service, which I'll come to that inside Kubernetes, so that will actually expose our pods, okay, through this something called as kube proxy. Basically this does all the networking stuff. And then finally we have the container runtime. So basically this is nothing but your Docker. Basically this actually runs all of our pods or your containers basically using Docker. So basically it will pull the image from Docker Hub, and then it will create a container based on the image that is specified. So this is what is responsible to run the containers inside this pods. Okay, so these are the containers. So let me just recap. Kubelet will directly communicate with the API server from the master node and then give the status of each pod. And then the kube proxy does the networking stuff. Basically when we want to expose a particular pod or a container, that it has to run on the specific port, and then this container runtime will actually run containers inside our pod, okay, based on the Docker image that we have actually published, and this will actually run containers based on that image. So I hope you have understood the internal architecture of a Kubernetes cluster. All right, so I've just considered one particular worker node. So usually in practice we will usually be having multiple nodes. Okay, so the question is, how can I start a cluster locally? So basically all these clusters will basically contain inside a cloud provider like AWS or GCP, where we start a Kubernetes cluster and then we communicate with that. So basically if I want to run it in development, so basically if I want to run this locally, we can run a cluster using Minikube. So basically this will create a cluster, and then it will give us access to the kubectl, and then it will run a particular cluster and manages the number of nodes. Basically we need to specify, so everything we specify within this command line interface kubectl. So let us go ahead and install Minikube and set up a cluster locally and try to run our application inside this. So now let's go ahead and install Minikube. Alright, so whichever the operating system you are using, you can just select the appropriate one and click on download. Alright, so if you are using Mac OS, you can also use Homebrew as well, or there's another alternative way of using curl, where you just copy paste this in your terminal and it will install Minikube. Alright, so once you have installed Minikube, so you will also require a driver. Alright, so if you are having Docker already installed on your particular machine, so you will be fine. So you just need to use a driver along with the Minikube that we start, basically where exactly our exact Minikube source code will be running. So that is inside Docker. So there are other drivers as well, so Docker is the ideal one. So once you have installed Minikube, we can just verify by using our terminal, typing Minikube, and if this actually runs, if this shows some output like this, which means that it has successfully installed. So now let's go ahead and create a cluster locally within our system. So whenever we are starting Kubernetes, so basically Minikube inside Docker, we need to make sure that Kubernetes is enabled. Okay, so we can just enable that by going to the settings, and on the left hand side you will find a tab for Kubernetes. So we need to make sure that this is turned on. Okay, so it says start a Kubernetes engine for multi-node cluster when starting Docker desktop. Okay, so if this is disabled, then your cluster will not start. Okay, so now let us go ahead and set up a Kubernetes cluster locally, all right, using Minikube. So we can just say Minikube start. Okay, and as I told you, we need to set up the driver, so we need to specify the driver, set this equal to Docker, and also we can specify the number of nodes that we want to work upon. Okay, so we can just say dash nodes. Okay, so by default it might start 1 or 2 nodes, so including the master node and worker node. So in order to explicitly mention the number of nodes, so we can just specify this to 3. Okay, so basically one will be the master node and the rest will be worker nodes. So we can just click on enter. So now this will go ahead and create a cluster for us with these 3 nodes. Okay, so let's wait for it. So in case you want to add a extra node, so if you want to add a 4th node, you can just say Minikube add node add, so this will add a 4th node. Okay, so this actually doesn't matter since we are just developing this locally. Once we are pushing this for production, so basically we want to set up a cluster on AWS EKS, and over there whenever we are setting up a cluster, it will ask us the number of nodes that we want to set up. All right, so over there we can actually configure, but in development it doesn't matter. All right, so let's wait for this to install. Alright, so now if you get a message saying that kubectl is now configured to use Minikube cluster, so which means that our Kubernetes cluster is set up successfully within our local system, so we are good to go with using kubectl. Okay, so if you just type kubectl, so it will give us some commands without any errors. All right, so which means that it has configured correctly. So we can just verify by checking the number of nodes that we are currently having by saying kubectl get nodes. So we should be getting 3 nodes with 1 node as the control plane or the master node, and the other 2 is the worker nodes. All right, so worker nodes, I told you that it is nothing but like your virtual machine if you are actually deploying it on the cloud. Okay, so currently we are having 3 nodes, and over here you can also check the number of pods that are actually running within your cluster, saying kubectl get pods. So currently we do not have any pods, so it says no pods are available in the default namespace. All right, so now let us go ahead and create pods. Okay, inside our 2 nodes that we are actually running. So basically in order to create pods, just as I told, we need to write a manifest file, right? So basically we just don't create pods directly, we basically create a replica set, and the replica set actually create pods. Okay, so instead of individually creating pods one by one, basically let's say I want 3 replicas of my backend application, so I don't have to like create one by one. So basically I create a replica set, and then that replica set creates pods. Okay, and in order to create a replica set, we actually use a deployment. Okay, so we create a deployment creates replica sets, and replica sets actually create pods. Okay, so I know this sounds a little bit confusing, so let us understand a little bit deeper. So we learned about 3 concepts. One is a pod, and the second one is a replica set, and third is the deployment. Okay, so what is the difference between these? Okay, so whenever you're creating a pod, which is also a resource in Kubernetes, basically you can create a manifest file or with the kind property set to a pod. So okay, so we can create multiple pods. Like let's say for in our example we wanted to create 3 pods. Okay, so we need to create 3 resources for this in order to start 3 pods. All right, so instead of creating 3 pods manually, what you do is you create something called as a replica set. So this is also a resource in Kubernetes where you set the kind to be a replica set, and inside a replica set you mention the number of pods that it has to run. So let's say I want to run 3 pods, so this will go ahead and create 3 pods. All right, so that's the only difference by creating a pod directly and by creating a replica set. Okay, so in a replica set you mention you want to run 3 pods and you run this particular replica set, this will go ahead and create 3 pods. All right, so what is the use of this deployment then? So if a replica set creates 3 pods, then why do we need a deployment? So that's the question, right? So there's one main thing that a replica set cannot do but a deployment can do. Okay, so that is basically rolling updates. For example, I have let's say I pushed an image, right? If you remember, like to do app latest. So basically this is the latest version. So based on the version, let's say I bring up a new version, so I rename the tag to be 1 instead of latest. So I keep on incrementing the versions. Okay, so now I just go ahead and deploy this. So basically I change my image name and go ahead and deploy this latest version. But one thing that replica set cannot do is it cannot do rolling updates. So let's say we are deploying this particular version 1 and for some reason it failed, so it will not destroy our previous pod, that is our latest, or whatever tag I have given, it will not destroy that. Once this particular pod is succeeded, okay, so once it's successfully running without any errors, only then will it go ahead and it will go ahead and delete the previously running pod. Okay, so that's the only thing that a deployment can actually do and a replica set can't do. Okay, so a replica set still can manage pods. Okay, so basically if 3 pods are actually running or not, even if you try to delete them, it will bring back up, but it cannot do rolling updates. So that only a deployment can actually do. So that is the main reason why we create a deployment in the first place. So basically a deployment will create a replica set and a replica set creates pods. All right, so that's the only difference between these kind of resources. So now that we have understood the 3 main concepts, that is deployment, replica set and pods, so let's go ahead and create a YAML file and then apply that particular file in order to run the desired number of pods within our existing nodes. All right, so let's go to our file and let's create a file. Let's call this deployment.yaml. So basically YAML is nothing but like a JSON syntax. In JSON we just use curly braces, but here we just use indentation. Okay, so basically if we indent with 2 spaces, which means that it is inside the block. Okay, so let's come to how we can actually write. So the first thing which we always need to mention whenever we are writing a Kubernetes file or the manifest file inside Kubernetes is the API version. Okay, so we just say API version and we just need to set up whichever the kind of resource that we are using inside Kubernetes. So currently we are using the deployment, so that is existing inside this apps/v1. Okay, and the next step is to specify the type of resource that we are giving for this Kubernetes file, that is kind. Okay, so we just need to specify this to deployment. Okay, so this can either be a deployment or it can be a replica set. So I already told you the difference, right? So if you want, you can directly create a pod, and I told you, right, so this will not be managed by Kubernetes. So in case we want to do a rolling update, so this will not actually work. So that only works in deployment, right? So let us go ahead and use a deployment over here. So once we specify deployment, we need to give this certain names. Okay, so basically we do that inside this metadata. Okay, so inside this metadata, so once you indent 2 spaces over here, which means that it is inside this particular block. Okay, so here we can just give this a name and we can just call this to-do-app because that's the name of our application. Once we have named our deployment, so in the next block we just need to specify the spec. Okay, so basically we just need to give all the specifications related to this particular deployment. So the first step is the replica set. Okay, how many replicas of the number of pods do I want this particular deployment to manage? All right, so we can give that within replica set. So setting replicas, and I'm going to give this to 3 for now, just for an example. So the next thing is I want to actually inform Kubernetes that which are all the pods that this particular deployment has to manage. Okay, so basically I have given 3 replicas, which means that if I have 3 pods, so in case if a pod goes down, so the number of pods becomes 2 for some reason. It will, as I told you, using that kube controller, it will constantly keep checking if there are 3 pods running. So if not, it will create another pod. Okay, so basically how will it identify which are all the pods that it has to manage? So by giving this a selector. Okay, so basically which are all the pods it has to manage, and here we say match labels. So whichever the pods that have a label of app set to do app, so this will get managed by this particular deployment. Okay, and within the same level of the spec, we also need to specify template. Okay, so basically we just need to name our pods. Basically whenever we are creating these replica sets, so with this 3, so we just need to name them as well, right? So by saying template singular, and here inside again we specify metadata, and over here we just need to specify the labels. Okay, so labels, so whenever it starts pods, it will get named by this particular label of app set to do app. Okay, so I hope this is clear. So what we are doing here is the resources deployment. We are giving this name of to do app for deployment, and we just need to specify the number of replicas, that is 3. So basically it has to start 3 pods, and whichever the pod that has a particular label called to do app, this will get managed by this deployment, and we are naming this pod. So whichever the pod that we are starting, so for each pod will have the label of app set to do app. Okay, so the next step is we just need to specify the image. Okay, so where it has to get pulled from. Okay, so inside this particular template, we just need to specify the list of containers. Just as I told, a pod can hold multiple containers, right? So we can give that in the form of a list. So currently we want to just run one particular container, so we can just give one item inside that. So inside this same level of this metadata inside this template, so we can again specify spec, and inside spec we have containers. So basically this takes in a list where we just need to specify the details of our container. Okay, so first thing is we just need to specify name, so we can just call this to do app. So this will be the name of our container. So what is the image URI? So basically whenever we push this to Docker Hub, this will take the pull from there and then run it inside that container. So I haven't yet pushed my image to Docker Hub, so I can just leave this blank for now. So after I complete this particular file, let us push our Docker image to Docker Hub and get that particular link, and then replace this with that. Okay, and also we need to specify the ports. Okay, so where this particular container is running from. Okay, so we specify ports, and this will again take in a list. So we just specify the container port, so by giving it a dash, and set this to 8080. Okay, so this is where our actual application is running on, so that is on port 8080. So this is all that we need to specify in order to create pods in a Kubernetes cluster. Okay, so now let's go ahead and deploy or push our image to Docker Hub. So basically I have already built my image, so all I just need to do is I just need to tag and then push it to Docker Hub. Okay, so once you push your image, you will get a particular URI. So based on that URI, this will we just need to replace this image with that, and then this will actually create a container based on that image that we push to Docker Hub. So now let's go to Docker Hub and create an account over there. So I'm just going, so over here we can just search for Docker Hub, and here we just need to first create an account. Okay, so let's first create one. So we can just click on sign in, and over here I have already signed in, so I can just sign in directly. So once you have logged in, you can just click on create a repository. So I had this repository previously which was created. If you don't have anything, it will show you no repositories. So you can just click on create repository and give this a repository name. So I'm just going to call this to do app. Okay, so let's create this as a private repository, so that I just don't want to publish this and allow anybody to access my particular application. Basically this contains all of my secret variables and all, so that's why I'm creating a private. So once you can click on create, this will go ahead and something went wrong. Let's try this again. So now my repository is actually created. Okay, so in order to push my application, so we can just say docker push and this particular, basically this is the username and this is the name of our repository, and give this a tag. Okay, so if you don't specify the tag also, it will just give it as latest. Okay, so we can just copy this particular command and first build our application and then push it to Docker Hub. So let's specify docker build. So this time I'm giving this tag of not just a random tag but the actual username that I have, so that is tanuj/to-do app, and I'm going to give this a tag of latest. Okay, so anyways this actually tags as latest, so give this a dot. So let's build our application. So once we have pushed our Docker image to Docker Hub, okay, so now we can just go back and verify if our image is actually pushed. So we can just go back and just give this a refresh. So we should be able to see an image with a tag of latest been pushed. Okay, so as you see over here, so our image is successfully pushed to Docker Hub. Okay, so in order to take a pull, we just need to say docker pull this image name, and this will actually take the pull. So let's now go ahead and use this within our deployment file. So now let's go ahead and apply this deployment file. All right, so now in order to apply the deployment file, so you say kubectl apply, so apply -f and then give that your file name. Okay, so that is deployment.yaml. So once you hit enter, this will go ahead and create your 3 pods. Okay, because I've given replicas to 3. So now if we go ahead and do a kubectl get pods, so I should be able to see 3 pods starting up. Okay, so it says that container creating currently. So in order to run this in watch mode, you can just say --watch. Okay, so here it's giving me an error saying that error in image pulling. Okay, so you see that there is an error, right? So it keeps on trying again and again, because as I told you that whenever it keeps constantly checking that whether our 3 pods are actually running or not. Okay, so after a certain period of time, it will check that if there is constantly getting errors, so that time it will actually stop. Okay, so that's the main reason why we want to create a deployment. It always ensures that 3 pods are up and healthy. All right, so let's go ahead and quit this and make sure that our image is pulling in the right way. If you remember, we had when we pushed our Docker image to Docker Hub, we created in a private repository so that nobody else can actually access. So that is the reason why it is not able to pull, because it requires credentials, right? So your username and password. So along with giving your image name, so you also need to give your the username and password. Okay, so we cannot expose your username and password just like this in our deployment file. So we can create something called as a secret. Okay, and giving that secret a name, we can just assign the value to that, so that it will infer from the value which is given in secrets, and that will not be exposed. Okay, so in order to create a secret, so we can just go back to a terminal and we can just type in the following command. So here you say kubectl create secret, and over here we need to mention 2 parts. One is the Docker registry, basically what type of secret it is. So basically it's a Docker secret, right? So we say docker-registry, and then the name of our secret. So we can just specify any name, and this name we can assign within our deployment file. So let us call this like Docker secret or something. So let's call this Docker Hub secret, and here we need to specify our secret. So we specify saying --docker -username, and give this your username, and then you can give your password saying --docker -password, and set your password. And after that we need to finally give our email, okay, that we had registered using that email. So we said docker --docker email, and give this your email. So now let us hit enter, and this will go ahead and create our secret. Okay, so we can just use this particular secret within our deployment file. So we can just copy this particular keyword and go to our deployment file, and right below the spec we can give it something called as secrets. So right next to the containers we can give this image pull secrets. Okay, so make sure you spell this right. So image pull secrets, and this takes in a list which we can just say dash and then give this your name. Okay, so we give this name and then we paste in that particular value. So with this done, we can now go ahead and rerun our deployment. Okay, so now let us go ahead and apply the deployment file. So now let us check the logs. So sorry, let's check the number of pods. Okay, so again it says error image pull for some reason. So let us go into watch mode. So in order to see what exactly is going on inside your exact pod, you can just copy this particular pod name, and we can just do a kubectl get logs for this particular pod. Okay, so kubectl logs, and then give this your name of your pod, and this will give us the exact log. Okay, so here it says that it is waiting to start, image can't be pulled. Okay, so actually I gave the wrong password, that is why it was giving me that error, image cannot be pulled. Okay, so now let's go ahead and rerun this particular deployment file, as I have now changed my password. So now that we have changed something, so basically we have given a secret, so we just need to reapply the deployment file. So we can just say kubectl apply -f and then this deployment file. Okay, so let's now check the pods by saying kubectl get pods. So this containers are actually successfully running, and let us now check this again. So whenever you see something like this, you just need to copy this pod name and just delete it. Okay, so this will actually go ahead and restart it. So we can just do a kubectl pod, delete pod. Okay, so this will go ahead and delete the pod, and it will bring a new pod again. So now you see that for the first time the status is container creating, and now our containers are successfully running. Okay, so now that our pods are like successfully running, in case you just try to delete them, it will just try to create a new pod. Okay, so that is the main feature about creating a deployment. So whenever a pod dies, it will just try to bring back up. Okay, so this is all about how you can write a deployment file and create pods. Okay, and inside our pods our actual application will be actually running. Okay, so now is the time to expose our pod so that anyone in the outside world can actually access our containers. So usually we cannot directly access the pod, whatever it is running inside that. Okay, so for that, in order to access our application, we need to create something called as a service. Okay, so service is also like a manifest file, just as how we wrote for this deployment. So we need to create another resource for the service, and over there we need to expose our pods. Okay, so there are different actual types how we can actually expose our pods. Okay, either we want like just internal communication, or we want the outside world to access the pod directly, or there are many other types. So let us go ahead and understand a little bit deeper. So now let us understand what are services. So let's say there are some containers that are running inside our worker nodes. So let's say we are running 3 pods, so like 2 pods here and 1 pod over here. So we are running 3 pods, and inside pods, our container is actually running. Okay, so now we are able to successfully spin up a pod, and inside there our containers are actually running. But the problem is, how can we as a outside world person be able to access the application that is running inside our pod? Okay, so that is where services comes into picture. Okay, so we cannot directly access this pod's IP address, and then whichever the port it is actually running, we cannot actually access it directly. Okay, so when it comes to a Kubernetes world, we always need to create something called as a service. Okay, which is also a type of resource which we actually need to set up. Okay, so basically there are 3 types of most commonly used services. One is the cluster IP, so I can just write this down. So cluster IP, so I'll just come to what they are actually. One is the node port, and finally we have the load balancer. Okay, so basically when it comes to cluster IP, so let's say I have a database that is running in this particular pod. So our database is actually running here. So basically I do not want to expose my database, so I just want internal pod to pod communication. What I can just do is I can just create a cluster IP. So cluster IP, and over here whenever any request comes, so basically this pod wants to communicate to this particular pod, so I can just communicate through cluster IP. Okay, I don't have to expose this database, so we don't even have to expose our database. So basically any request that comes to this pod will go ahead and utilize this database. Like for example, when we want to register a user, so that will access this database. So that is where cluster IP comes into picture, where we do not expose our pods to outside world, just for pod to pod communication. All right, so the next type of service is called as a node pod. So if I want to expose my pods to the outside world so that anybody can access my pods, okay, so that's where I can use node port. Okay, basically node port exposes the IP address of your particular node. Okay, let's say this is the node port service, so that is running on a very large number port, so let's say 32,000, and whenever we make request to this, so this particular node port service will route our traffic to any one of these pods. Okay, so you might think that this is a different node. Okay, so this node will have different IP, this node will have different IP. It doesn't matter. So let's say this node has a IP address called 1.2.3.4. okay, so it doesn't matter, it can go even to this node or it can go even to this node. So even though this node has 1.2.3.5 for example, so it will route to any one of these pods. Okay, so maybe in a round robin fashion or whatever the algorithm that Kubernetes uses under the hood. Okay, so basically, as I told you, inside the pod we have something called as the kube proxy, okay, which is responsible to do the networking stuff. So that is actually responsible over here. So whenever a request comes over here on this port 32,000, so this will go ahead and route our traffic to this. Okay, so this is how we as a user can communicate from the outside world using this node port service. Okay, so everything is good using node port service. The only problem is we are exposing the IP of our nodes. Okay, so basically let's think this is an EC2 machine, so we should not expose our EC2 machine's IP. Okay, so that is a bad practice. So that is why we do not usually use node port when it comes to production. Just for the sake of development we can go ahead and use this, so that is not a problem. So the ideal approach in order to expose our pods so that I can expose my pods to the outside world is by using a load balancer. So this is typically used in production. Okay, so load balancer doesn't come with Kubernetes, but whichever the cloud provider that we are using, for example AWS, so it has its own load balancer. If I'm using GCP, it has its own load balancer. If I'm using Azure, it has its own load balancer, right? So load balancer is something that doesn't include in Kubernetes. We need to set it up. So in our service file we just need to set the type to be a load balancer. So whenever we are actually creating a cluster in the cloud and run that particular file, this will actually create a load balancer. Okay, so basically we have a load balancer here, so I'll call this LB. So whenever any request comes to this load balancer, will go ahead and route to any one of these pods. Okay, so this is load balancer is something which doesn't include in the cluster, but we need to set it up outside it, and whichever the cloud provider actually is specifying it, that load balancer we need to use. So for example AWS has ELB, Elastic Load Balancer. Google might have something else, Azure might have something else. Wherever I want to deploy my application, all I just need to do is set up a cluster over there. It will use its own resources or its own services. For example, this nodes. Okay, so in AWS it is EC2, in GCP it might be something else, and irrespective of whichever cloud provider you are actually using. So every cloud provider will have its own services and it will utilize that one. Okay, this is the ideal approach which we always need to do in order to create production level applications. Okay, so we don't use node port, that is just for development, and we always need to choose load balancer. So now let us go ahead and try to expose all of these pods within our local using node port, as I told you, for development, and later as we deploy this application to maybe AWS or any other platform, we use the load balancer over there. So now let us go ahead and create a service with the type set to node port and just try to access our application that is running in these pods. So there are two ways of creating another manifest file. So basically this is for the deployment. If I want to create another same manifest file with a different resource, I can put in 3 lines over here saying dash dash dash, and over here I can just write in my second manifest, basically if you want for a service, for example. Okay, so I'm just going to create another file, so if you want you can just write this within the same file as well. So let's go ahead and create another file for the service. So I'm just going to call this service.yaml. Okay, so over here let's go ahead and define our service. So basically the service resource is actually available in the API version v1. Okay, so in the deployment it was app/v1. Okay, so different resources will have different API versions, so you just need to understand that. So let's go ahead and specify the API version. So this is going to be just v1 this time, and next is we want to specify the kind, that is service. Alright, and then we want to specify the metadata. Okay, so basically here also we need to specify metadata such that which are all the pods that it has to match and expose it. Okay, so we just want to match all those pods that are having the label called as that is app colon to do app. Okay, so let's specify metadata, and over here we just need to first give this a name, and I'm going to call this to do app service. Alright, and here we just need to provide labels. Okay, so which are all the pods that it has to match, so labels, and this has to take in a value that is app set to do app. So over here we also need to specify the spec just as we did for deployment. So inside the spec we just write selector, so which are all the pods it has to kind of select, and we want to select the pods that are having a label of to do dash app. So over here we are specifying two times. So the first time is basically whenever we are starting this service, these are all the labels it has to match. Okay, so we need to make sure that this S is a capital. Okay, so the next thing is we just want to expose the ports. Okay, which are all the ports that it has to expose. So we specify ports, and this will actually take in a list. So we say dash and then give this a port. Okay, so which is the port where our actual application is running, that is on port 8080, right? So we specify port 8080, and the next is the target port. So basically the target port is where exactly our actual application is running inside the container, and this port is what will be exposed. Okay, so basically outside the container. So we specify target port, and we just give this a value of again 8080. It's just like how you specify port mapping in Docker, right? So it's similar to this, but here we are just giving in the form of a file. So we specify next is the protocol, which is actually mandatory to specify. So this is running on TCP. Alright, and finally we just need to specify the most important part, that is type. Okay, so as I explained, there are different types, so we are going to use the node port. Okay, so basically it just exposes our pods, sorry, not pod, that is node's IP address. Okay, so we can just say type and give this a node port in the same level of these ports. So type node port. So okay, so make sure you maintain the case. So let's go to our terminal, and in order to apply this file, as I told you, just how we did for the deployment, we can do the same for the service file as well. So we can just do a kubectl apply -f and give this the name service.yaml. Okay, so let's run this. So I'm getting an error here. So basically I made a mistake. So this ports should be inside this selector. Okay, so I just need to move this indentation a little bit left like this. Okay, so now let's save this and run the file again. So over here I have applied my service file. It says service actually created. Okay, whatever the name you have given. So you can just verify by saying kubectl get services. So get svc. So this will go ahead and fetch all of your services that you have. So it's kind of slow. So now in order to run your application, we need to say minikube service and then give this to your service name. So the service name that we had provided is this to do app service. So let us paste this right here. So this will actually take you to the exact port where our actual application is running. Okay, so it's kind of slow. Let's wait for it. So it will just take you to the browser, and there you see your application running. All right, so this is basically localhost, and this is a very big range of port. Okay, so that is used by Kubernetes. So it starts from like 30,000 and goes all the way up to 60,000 and more than that. Okay, so just don't worry about this port. So in order to change this port also, you can just configure that within your service file. So which exact port you need to use. So this has to be a large number. So the best part is we are now able to access our application. Okay, so let's now go ahead and test this inside Postman by copying this URL. So I am going to just get all of my to-dos and just let's click send, and we are getting token expired. At least we are getting some response, so that's a positive thing. So let's go ahead and register a user. So now I am able to register a user. So let's go ahead and log in. Actually, I don't know. Whenever I on my recorder, it's getting hanged. So whenever I stop the recording, it actually makes the request. So maybe there is some blockage from this recording. So now that we have understood that everything, all of our APIs are actually working, and we just saw that our actual application is working. So okay, so we have exposed our pod using the node port, so everything is working as expected. So we have just tested by getting one of those pods IP and the port, and we have tested it in postman. So now let us understand some more commands in case you want to debug. All right, so basically if you want to get which all deployments are available in your Kubernetes cluster, you can just do a kubectl get deployments. So currently I just have one deployment, so we say deployments, and this will go ahead and fetch your deployments. Okay, so this is my name that I have given, that is to do app. Okay, so it's inferring to this particular name right here, to do app, and here how many nodes are actually running over there, sorry, how many pods, and which are up to date and available. So if there is any pod that is not running in its healthy state, it will not show 3 out of 3, it might only just show 2 out of 3, and it will just keep trying to start another pod, and unless it succeeds, okay, and it will delete our previous pod. So that is how exactly a deployment works. All right, so this is how you can get deployments, and I have already told how you can get pods by saying kubectl get pods. In case you want to get detailed pods, like which pod is running on which node, so you can just do kubectl get pods -o and then wide. Okay, so this will give us more information about the pods. So this is the pod ID, how many containers are running, so 1 out of 1 containers, and it is running. So this is the IP of that, and this is the node on which it is actually running. All right, so these are all the verbose logs of each pod. Okay, and currently you see that we are running 3 pods. Each node is running 1 pod each. Okay, so if you remember, I had told you that master node doesn't run any pod, but when it comes to development, actually using Minikube, it actually runs a pod even there. But when you spin up a cluster on the cloud, okay, there your pod doesn't run on master node. Okay, so over here in Minikube, somehow it is running even on master node. So that's the point to be noted. So we are running 3 pods in each of the node, and we have already exposed by using a service over here. Okay, inside our cluster we have set up a node port which will route the traffic to any one of those pods, okay, based on the many metrics like CPU utilization and all that stuff. So which is the best pod it has to route to, it will route. Okay, so in case you want to check the logs of pod, so you can just say kubectl logs and then give your pod name. So that is this one. All right, so this will give us the logs. Okay, so as you see, our server is running on port 8080. Okay, so if you have a look at the logs for the other pods as well, you will get the similar message like this. So this is how you can check logs. And in case you want to check the description of a particular pod, you can just copy the pod ID and you can just say kubectl describe pod and then give it your ID. So this will give us all the information that we have within this particular pod. All right, and this is all the other information, which namespace it is actually running, which I'll come to what is exactly a namespace, what is the IP address, and which actual node does it belong to, and what is the container ID, the Docker container, and which image is it pulled from, all of these stuff. Okay, so you can just have a look. And if you want to get your services, so you can just do a kubectl get SVC, which is short form for service. So currently I do not have any service. Basically this is the default service, which is cluster AP, which is used for pod to pod communication. So in case you want to create a service, as I told you, you need to do minikube service and then your service name that we had mentioned over here, that is to do app service. So we can just expose all of our pod using node port. So this will go ahead and so actually I forgot to apply my service. So in case you don't apply any service, you will get some error like this. So okay, so let's apply our service file. So our service is now created. So now we can just do a minikube service to do app service. So this will go ahead and expose our particular our pod onto the browser. So this is the IP address. So this is localhost, and there we see our application running. So in case you want to say API/todo, we will get all the to-dos which we have already seen. Okay, so these are some of the commands, common commands that we use inside Kubernetes. So now it is time to deploy this onto the cloud by creating a cluster on the cloud. So far we have just done this locally. Okay, so nobody else can actually access my application by hitting this particular route, since this is localhost. So let us go ahead and create a cluster in AWS, and over there we use the EKS, which stands for Elastic Kubernetes Service, and specify all the stuff and then create a cluster. And based on the config file that it actually provides, we just need to connect it locally, and then whatever commands we write will actually hit the Kubernetes cluster that is hosted on the cloud. Alright, so let's get started. So in order to set up a Kubernetes cluster in AWS, we need to install a specific CLI, so specific to AWS, so that is called as EKS CTL. Okay, similar to kubectl, so this is specific to EKS. Okay, so basically this will make things very easier. Instead of us going and spinning up EC2 instances, load balancers and all that stuff, and providing the region, the number of nodes, all that stuff, we can just use the CLI. Okay, so let's go ahead and install that. So currently I'm using Homebrew, which is actually specific to Mac, so I'm just going to install using Brew. I'm sure there is something similar if you're using different operating systems, so you can just do a Brew install if you're using Mac. EKS CTL, so it's similar to kubectl, so we can just go ahead and install that, and let's wait for it. So once it is installed, you can verify by typing EKS CTL and give this a version, so which version it is. So basically it returns us some valid information, which means that it is actually set up. So I'm not sure if this is the command, so is it -- version, or I'm not sure. So if you just type in EKS CTL, maybe it should give us a list of commands. Yeah, so which means that it is successfully installed. So once we have installed the EKS CTL CLI, we now need to create a user. After creating that user, we need to log in using the AWS CLI. Okay, so if you just type AWS, if you have the CLI, it will give us some output like this. Otherwise we need to install the AWS CLI. Okay, which I have already done this in my previous video. So let's go ahead and create a user first and then try to log in. Once we log in, we are good to go with creating a cluster in AWS homepage, and just search for IAM. Okay, so basically this is handle the access to certain services inside AWS by the root user. Okay, so we can just go ahead and create a user. So if you click on users, so this will give us a list of users that you actually have when you're logged in as a root user. So basically I already have a user, so if I just open this, all my credentials will be shown. So basically if you don't have a user, you can just click on create user, and you basically need a access key and a secret key. Okay, so once you create that, we can just go ahead and log in inside our AWS CLI. I'm sure like once we have done this before during deployment, so we can that's the exact same process which we need to follow. So let's go ahead and open our terminal, and here we can just type AWS configure. Okay, so once we hit enter, so this is it will ask you for the access key ID. So if you already had entered previously, it will just show something like this with some characters masked. So I'm just going to go with this, and also the access key, and then this is the secret access key, and this is the access key ID, and this is the region name where you want to access. So this is basically in the Mumbai region. So this is, I'm just going to leave the rest as default. So now once we have configured, we can just go ahead and use the CLI in order to create a cluster. So in order to create a cluster, we can just use a EKS CTL create cluster, and then give this a name, region, the number of nodes, and the node type. Basically it starts EC2 instance, right? So what kind of instance does it want to start, and then does it have to manage by itself, or do we need to manually manage? So we can just leave this to manage. So this is the actual command. Okay, so we can just go ahead and copy this. Basically I just chat GPT'd, so we can just use this inside our terminal. So I've just pasted it right here. Okay, so basically I can just give this a name of like to do app cluster, and this is the region which I had set it up even for the user, so that is the Mumbai region. So currently I'm going with 2 nodes. Basically these are the worker nodes. Okay, and this is the node type, which is we can just set this to T2 micro, where there's a free tier eligible. So we can just let this to managed, and we can just go ahead and click enter. Alright, so now it's saying building cluster stack, okay, and deploying stack. So Let's wait for this to complete. Okay, so our cluster is now set up in AWS. It took a bit of time because it needs to create all those nodes and all that configuration stuff. If you see a message something like saying EKS cluster, your whatever name you're given in the particular region, you're good to go. Okay, so you can just go back to your AWS console and verify if your cluster has been created. So over here inside of clusters, if you just give it a refresh, so you should be able to see your cluster by the name which you are given. All right, so this is the cluster which has been spinned up. So let us also verify if our two nodes, basically I told you nodes are nothing but EC2 instances, right? So if they are created or not. So you can just go to EC2 and just check if those two nodes are actually created. So you see that instances running are currently 2. Okay, so if you just go to instances here, so you should be able to see 2 instances of this to-do app cluster running. All right, so which means that our nodes are currently running and they are also in a good condition. So once you have verified everything is working, now we can just go back to our terminal and just operate using kubectl. Okay, so we can just go back to the terminal and we can just do a kubectl get nodes. Let's see which are all the nodes we have. So basically these are the two nodes. Okay, so which means that it is actually connected. So you might have a question right now, how does kubectl know which exact cluster does it have to manage? So previously I showed you the same command kubectl get nodes in minikube. So how does it now access the cluster that is set up in the cloud? Okay, so basically when you go to this particular folder called as .cube, the root directory, if I just do a ls-a, so which lists all the, so this is the folder called as .cube, okay, where exactly our configuration is set up over there. So if we just do a cd of .cube, so currently if we just check the contents inside that, this has a particular config file. Okay, so if I just do a vconfig, so this is the exact configuration. So this is your secret file. Okay, so if I give the secret file to anyone else, so they also can connect this with kubectl and operate our cluster. Okay, so we need to make sure that this is completely private and not share this with anyone as long as they do not want to operate. So now let us go ahead and quit this. Now we can go to our VS Code terminal and apply the deployment over there and then check our application if it is actually deployed. Does it even create pods on the cloud, on the cluster that we actually set up on AWS. Okay, so let's open our code editor and let's first of all get rid of this minikube service. So in order to get rid, you can just do a minikube delete. So this will go ahead and delete your actual cluster which is actually just set up locally. So okay, so once that's done, we can now clear all this and we can go ahead and apply this deployment file. Okay, so we can just do a kubectl apply -f and this deployment. All right, so let's check. Okay, so all of our things have been created. So I think I forgot to create the secret, so let us quickly go ahead and do that. So now I have set up my Docker secret, so let's rerun the exact file. So deployment YAML, so let's wait for it. So now it is been created, so we can just verify by saying kubectl get pods. So it's a bit slow because it's it's actually hosted, so we can run this in watch mode, so to check if our status is completed. Actually this is stuck in pending for about half an hour, but I don't know what is the reason. So let us check the logs, or just let's describe this particular pod. Okay, so let's check what is the reason. So here it says that I'm not sure if you can see this, so it says too many pods. Okay, so maybe the instance type which I chose was very small, so it is not able to handle like more than 2 pods, I guess. So now I have changed the instance type from T2 micro to T3 medium, because those instances were not capable of handling pods. So let's go with T3 medium. Anyways, after this video I'm just going to delete all of them. So what I did is I deleted my whole cluster and just started a fresh one, giving it the type of T3 medium. Okay, so now let's go ahead and rerun our deployments. So now let's apply our deployment file again and let's check if our pods are now creating. Okay, so our deployment is created. Now let's try to get our pods. Let's run this in watch mode. So actually try to debug the error. So this time the error was based on the Docker image that we built. So basically I built it on the Mac M2. Okay, so basically that was ARM64, but it was not compatible on the cloud. Okay, so the EC2 instance had a Linux AMD 64. Okay, so we just need to build by specifying the exact platform and then push our image to Docker. Okay, so let's copy this, and so now I just rebuilt my image using this exact command by specifying the platform. So I just pushed my image to Docker Hub. So all we just now need to do is restart our deployment. So I forgot to mention that this is how you restart a particular deployment. Okay, so we say kubectl rollout restart deployment and your deployment name. So let us go ahead and apply this exact thing. So let's paste this here. So this will go ahead and restart your deployment with your latest changes. It says restarted here. So now let's go ahead and like get our pods. Okay, so now we are successfully getting running status here. Okay, so we have been stumbled upon many errors. Okay, so this is completely a raw video, so I haven't implemented this previously. So I just came and show you all the possible errors that could happen while setting up while deploying application using Kubernetes. Finally, both of our pods are running, so we can just check the logs by saying kubectl logs and give that your pod name. Okay, so let's check if everything's running. Yeah, so currently it says servers running on port 8080. Okay, so previously we saw this on Minikube, but this time we are seeing it on the server, basically on the EC2 machine. Okay, so now let us go ahead and access our application, whatever is running on this particular port. So as I told you, in order to access our application, in order to send requests to this particular APIs that are running here, we need a service, right? So we just need to apply the service manifest as well. Okay, so if you remember, I told you that node port is just for development. So this time we have deployed our application to the cloud. I told you the ideal approach is by using a load balancer. Okay, so for that, let us change the type from node port to be a load balancer. So if you just change this type from node port to load balancer, it will create a load balancer whichever the cloud that you are using. So let us change this to load balancer. Okay, and apply this file. So we can say kubectl apply -f service.yaml. all right, so let's wait for it. Okay, so our service is now created. So now if we get our services by saying kubectl get svc, so we should be able to get one particular service of type load balancer. So now let us go back to our AWS. So here let us click on load balancers and check if our load balancer is created. So, and this was the load balancer that was just created. Okay, so as I told you, whichever the cloud specific platform you're using, that load balancer will be created. So our load balancer is successfully created. So currently it says 0 out of 2 instances in service. Basically it's still configuring, so we can just try this once again. So now we are getting 2 out of 2 instances in service. Okay, so now let us go ahead and access this load balancer. So if we copy this DNS name and just try to open this, so let's paste our URL and specify the port, that is port 8080, and yeah, there we go. So this is our application which is hosted on EC2, basically through Kubernetes. So previously we had hosted this locally and viewed our application locally and try to access it, but now we have hosted it on the cloud, so on EC2 using EKS. So this is I guess about this video. Let's now go ahead and clean up whatever we have created. All right, so in order to delete all of our deployments, so we just go back to our terminal. We just say kubectl delete deployment and give that your deployment name. Okay, so once I delete my deployment, I will no longer be able to view my application. Okay, so this will just keep on loading. And now also let's go ahead and delete our service. So svc. All right, so our service is now deleted, so nothing is there within our cluster right now. It's completely empty. So now we can just go back to our terminal over here. So in order to delete our whole cluster, we can just specify this particular command. So this is my name of the cluster, so I can just do eksctl delete cluster, the region and your name. Okay, so this will go ahead and delete our cluster. All right, so whatever the load balancers, the EC2 machines that were set up, we'll go ahead and delete. Okay, so if we just go back to our browser and just try to have a look at our EC2 machines, so our load balancers have first deleted. So now we just need to check our EC2 machines. So currently it's still running, so if you just try to keep refreshing, you'll see a state called terminating. So one instance is got deleted, and this one will be deleting. Also make sure that if any other service is created within your AWS services, make sure you shut them down. If not, you will get a bill. Alright, so that is all about this video. So this video was like completely raw, as I told. So if you have any questions pertaining to this video, so please let me know in the comments down below. So if you like this video so far, make sure you share this and like this video, and also subscribe for some more valuable videos just like this. So thank you so much for watching. I'll see you guys in the next video.